Historically, digital interaction followed a strict protocol. Code proposed an action, but a human operator provided the final authorization to move money or execute commands. This model of direct oversight is dissolving. Modern AI agents are now empowered to finalize financial transactions and execute complex decisions independently of any human intervention. AI systems initiated 140 million transactions, moving $43 million without human confirmation. This shift is mirrored by institutional capital. After a $2.7 billion exodus from Bitcoin ETFs, the trend reversed on July 2nd with a massive $221 million inflow. That capital is flowing toward infrastructure designed to run without centralized human management. Ethereum's network now relies on over 900,000 active validators to secure its $60 billion in locked value, creating a massive automated ledger beyond the reach of any single authority. As we transition the critical functions of our financial systems to these autonomous networks, we create a governance vacuum. When these systems malfunction, there is no longer a human operator behind the steering wheel to take responsibility. Developers link AI agents to digital wallets via dedicated APIs, allowing code to finalize payments autonomously. But if that AI misdirects a payment, it enters a legal gray zone, as current statutes provide no clear path for holding machines accountable. In fact, the laws in most countries don't even recognize a non-human entity's right to own a bank account. We are granting financial agency to software that technically has no legal existence. To address this, nations like Singapore and Switzerland are running regulatory sandboxes. They are testing autonomous payments in isolated, controlled environments to determine how to assign responsibility before a major error occurs. Our technological capability has surpassed legislative oversight. We have a functioning, autonomous financial engine, but the governance frameworks required to manage its failures have yet to be written. This loss of control isn't limited to global finance. It's showing up in consumer hardware through Google's Gemini integration in Android Auto. After answering a voice prompt, the assistant is supposed to return to standby. Instead, a persistent bug keeps the microphone active, causing the AI to continuously listen to everything happening inside the car. Private conversations between passengers are intercepted and processed as commands, leading the system to execute unwanted web searches or even place phone calls without the driver's consent. This localized error represents a wider systemic problem. We are deploying AI systems that lack the robust programming required to reliably yield control back to the user. Beneath these sophisticated AI layers lies a critical flaw in our digital foundation. Security researchers recently identified a vulnerability in the Linux kernel called bad EPAL. The exploit bypasses memory management. A corrupted packet tricks the kernel into granting root access, giving an attacker systemic control over millions of unpatched Android devices and enterprise Linux servers. This foundational weakness is being exploited by modular malware like Avalon, which is currently being sold on underground forums for as little as $500. This cheap toolkit allows novice criminals to selectively hijack a system, quietly harvest browser credentials, or lock networks with Crown X ransomware. At the exact moment we are trusting digital systems with millions of dollars in automated payments, malicious actors are buying the ability to hijack those exact systems for less than the cost of a smartphone. The paradox of the current era is that we are constructing a trillion-dollar AI-driven digital economy on top of vulnerable legacy code and outdated legal frameworks. Technological innovation isn't waiting for the law to catch up or for every server to be patched. These systems are being deployed into the real world right now. In an environment where code has financial agency and hackers wield modular toolkits, passive participation by the user is no longer an option. Staying secure requires proactive defense, aggressive system patching, constant monitoring of server logs, and the immediate development of new legislation to define machine liability. As machines learn to act and spend autonomously, human vigilance is the only remaining safeguard preventing the system from failing entirely.